In this tutorial, I'm going to show you how to think about climate data relative to building energy use. And we're going to cover where to find climate data, how to use it, what the format is, and different ways of manipulating it using different types of software. So let's jump in real quickly. In class, I'm going to go over in more detail what the visual essay entails. In this tutorial, I'm going to go over some of the nuts and bolts of how to assemble the bits and pieces. So you can see on the assignment here, there's several parts to this, and none of the parts are very difficult, but I wanted to break it down into small bits for you. The first thing you're going to want to do is go to the class folder, go to Climate, and download all of the materials in here. The assignment is here. This is another Excel template, which I'll go into more detail. Henson and Hootman are two readings, and this one is a zip file that contains all of the weather files for your climates. After you've downloaded that zip file, go ahead and extract it, and you'll see that there's several folders inside that zip file. I downloaded those files from the web, and let me show you how to access them, download your own files for future reference. You'll see on the assignment, under Resources in the bottom right here, I'm going to zoom in on it. It says that there's a T02a Climate Finder that's free under this name. That's a really cool one. And then there's one that's paid, that's this one. And I'm going to show you both of them. Let me open up the free one first. And this opens this website, which has all of the different, well, not all the free EPW files that you can find around the world. And it's very easy to search. So if I was looking for, say, Siraj's hotel in Coachella, I can go here to Coachella, and I see there's Coachella, and there's a EPW file here in Palm Springs Thermal. If I zoom out a little bit, I can also see that there's a few others nearby. There's one here in Palm Springs International Airport. There's another one here in 29 Palms. There's even another one over here it's called March Air Force Base. This is also nice that this comes up with a Google terrain map, and how this is helpful is that it's always good to try to find weather data that is in the same basic geographic area as your building, but also make sure that it's not across any large bodies of water or mountain ranges that would make the data very different. In this case, we lucked out. We've got some very good data very close by, and you can see that it gives the latitude and longitude there. I can double click on this and it will download that EPW file, and this is what I have for you in that folder. Now if you want to take another case, let's look at Astana in Kazakhstan, because this map does not have any files very close to Astana. In fact, the closest one is Semipalatinsk, which is about 400 miles away. It's a very long way. And although it's not, doesn't seem to be many geographic features like large lakes or mountain ranges that are different, they are distinctly different climate zones. And so you could download Semi and try using that. There's other places to check, though, if you can't find your data here. So I'm going to go back to this assignment, and under the paid climate data, you can see there's this weather.whiteboxtechnologies.com, and I'm going to try this one. And if I go to the TMY, I'm going to try IWEC first. This lists a whole bunch of different ones. You can see there are some free ones, which are also listed on the EPW map site. But then these, the IWEC2 and the CN2014, are paid, and they're generally about $35 per station. And you can see, especially in Europe, but actually if I zoom out, you can see all around the world, these IWEC files are quite common. Now I've got many worlds here. Let me zoom back into Kazakhstan. The search engine here is not quite as good, but if I zoom in to where Astana is, you can see that there is actually climate data here for Astana. And it's IWEC2. WMO is the weather data collection site. And I can add this to the cart and check out and pay for it with a credit card. And I've actually done this for the Astana group so that you've got as good data as we can possibly find. That being said, after downloading it, I compared it to the data at SEMI. It was interesting to see that they're very, very similar. I don't know if that's just a coincidence, but I probably didn't have to pay the $35. That's not always the case, though, so it's good to know. And hopefully this gives you a couple different resources for finding data yourselves. Now let's go back to the TMY data that you downloaded and unzipped, and we'll examine this data in a little bit more detail. I'm going to just start with Stuttgart since it's on top. You'll see that there's usually 3 or 4 files in here. There's a copyright and license, there's a DDY file, an EPW file, and a STAT file. Right now for this exercise, we're just going to use the EPW file, which stands for Energy Plus Weather. And we'll go into what that means in a couple weeks in more detail. But for now, you should know that this is a weather file, and as I discussed in class, this weather file is a typical meteorological year, TMY file. It's generally the last 30 years of data that have been compiled and analyzed to produce real-time data of the most typical events. And if I open this just with a text editor, you'll see that this is a file format that is called a comma-separated value format, CSV. It's called CSV because, I'll show you here what it looks like. Each one of the values is separated by a comma. So this is 1986, 1, 1, 1, 60, which stands for January 1st, 1 a.m., 60 minutes. And then there's a whole bunch of garbage letters here, don't worry about those. And then minus 1.9, which is the first value of temperature in Celsius. And actually, you can see here there's a whole series of comma delimited values that stand for different data. You'll also see that in this file there are 8,760 rows. That's one row for every hour of the year. You can see on the left that the year changes: 87, 92, 85, 82, and this is just a window into how these files are broken up as real weather conditions, but the most typical ones over this 30-year span. While I'm at it here in the text file, there's a whole bunch of information right at the top here, which is actually pretty much in English. You can just read it. Location Stuttgart, DEU, IWEC data 1078380, that's the station number. And then here's some important data. This is the latitude and longitude of the data. And we'll get to why that's important in a second. So there's a better way of looking at all this data, which is in a spreadsheet program. So I'm going to close this text file, and I'm going to open Excel. And from Excel, we can import the EPW file. I'm going to click on Open Other Workbooks, and I'm going to browse to the place where I've got this stored. Here's the Stuttgart folder. And you notice right off the bat it looks like there's nothing in this folder. That's because this is looking for an Excel file, an XLS file. This is an EPW file, but if you scroll up here and click star.star, it will show you all of the files that are in that folder. And what we want to do is open the EPW file. So click open, and now it'll give me a dialog box that looks like this. And it's a text import wizard, and it's asking you to choose the file type that best describes our data. In our case, we've got a comma separated value, so it's a comma delimited file. So we want to click on delimited and keep everything else as shown. Click next, and it says the delimiters, these are various options, tab, semicolon, comma, etc. We've got comma, so we want to unclick tab and click comma, and now we can finish, and it will import all that data into Excel. So you remember there were all the header information, and here at row 9 begins the data for the year, the first hour of the year. And if you go down to the bottom, there's 8,760 hours or rows. So now we want to take all this data and copy it into the spreadsheet template that you downloaded from the class website. I'm going to move this over to the left side, and I'm going to bring in that template here, and you'll notice that the template is already populated with some climate data. This is the one on the right. So there's a few tabs on the bottom of the template. Make sure you're in TMY data, and here's how you do it. Here's how you copy it. Click on the upper left hand corner. This is really important. That will select all of the data. Now press Control C, and you'll see this box kind of goes around here. And now go into the new template and press Control V. Make sure you're in cell A1 and press Control V, and it will overwrite what was there previously, and that will then update all of the other information. So this should be now the Stuttgart information that you get right here. Good. So that's step 1. Step 2 is to look and see where this data is actually coming from. I mean, you know that it came from Stuttgart somewhere, but what I want you to do is to map where this data was actually collected and map where your case study is, and see if there's any significant differences that you can tell between them. So back here, remember, we looked at the latitude and longitude in the comma separated value file, the text file. And we can actually navigate to that here by pacing along and find 48.68 and 9.22 as the latitude and longitude. I've also made this a little bit easier by referencing those cells right here. You can see that's referencing the other sheet. And so you can copy these, and what you want to do actually is copy them over to Google Maps. This is an amazing technology. It wasn't around when I was learning all this stuff years ago, but you can just simply enter the latitude and longitude right in Google Maps, and it will take you to that place. So 48.68 comma 9.22 will take me to Stuttgart, and you can see that the airport is right here. Most of the weather files that we have are from our airport data. So probably the data was actually collected somewhere over here, but there's a rounding error on the latitude and longitude which got us a few blocks away. For our purposes, this is great though. We know approximately where the data was collected. Now the question is, where is the case study building? Well, in the case of Andreas's building, it's in Erbach, and if I type in get Google directions from the TMY data to Erbach think it's Erbach im Odenwald. No, sorry, wrong Erbach. It's Erbach an der Donau. And so here you can see Erbach an der Donau there. And Google Maps also has this really nice thing where you can get the distance between spots. So if I right click on the map and click on measure distance, I can then, it says click on the map to trace a path you want to measure. So I want to get over to here, and I'm going to just align that dot there and this dot here, and I can see that it's about 40 miles. Unfortunately, I couldn't figure out how to change these to kilometers, but you can see down here the kilometers are listed as well. So we not only want to know the distance, but we also want to know how similar the geography is, if there's any major mountain ranges or lakes or oceans in the way. And the easy way to do this is I'm going to get rid of my driving directions here so that graphic goes away. And I'm going to click on the terrain function so I can see the terrain. And I'm going to zoom way out here so that I get a bigger picture. This is most of Europe now. But you can see the major geographic things. The Alps to the south. This is what is this, Lake the Bodensee here. It's a pretty major body of water. There's the Rhine flowing down here, so the Rhine Valley has its own effects. And there are some smaller hills, it looks like, in here. I'm less familiar with this topography. But so there might be some small differences, particularly in wind direction. But on the whole, this looks like a really nice match with between the climate data and the building site. So please take a screenshot that gives a decent overview. I think this kind of shot, and for this particular instance, is a good one. And I'm going to do a screen capture here using the snipping tool and just do a Windows snip and save this as Google Maps terrain distance. And then I can crop this later in InDesign. Okay, good. So now going back to the climate data, I think we should take a look at the bulk of the data. Every single one of these data cells is a category of data that was collected. Remember, the rows are the hours of the year, and the columns are the different variables that were measured. Or these columns have headers. And I've got here under TMY key the key to all those headers. And what you can do is copy row 8, if you're curious, and insert it above row 9. So highlight row 9, right click, and insert copied cells. And you'll see the header information for each of these. So date, 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 hour, minute, dry bulb temperature, dew point temperature. Some of these are quite long, and so if you look up here, you can see the full heading. You can also see the full heading by double-clicking on the right-hand side of one of these columns. You could also select them all, like this, and double-click, and they'll all automatically size. So dew point, relative humidity, atmospheric pressure, horizontal radiation, direct normal radiation, etc., etc. I'm not going to go through every single one. But you can see there's a lot of data that's generated here and is really useful. One thing to do is to scan the data and make sure that there's no bad data. You can see that this goes from 0 to 400 to 2800, etc. So this looks like good data. If we go to the right here, you'll see that there's a few columns that probably have zeros in them. The present weather observation is all zeros. The weather codes are nonsense. The precipitation is all zeros. The aerosol optical depth is all the same number. The snow depth actually looks like, in this case, it is collecting some data. which is unusual. I almost never see that. I don't know how reliable that data is. And then days since last snow is also not, it's all 88s there. So it's important to check the veracity, the truthfulness of the data to make sure that you're looking at things that are reasonable. If you find any problems in the data, please ask me or ask Luis, or we can discuss it in class. So this looks good. And now down here, there's a week tab and a year tab, and I want to go through these. The week tab has a whole lot of data in it, and you can read the red text here. It says scroll right for graphs and check yellow highlighted cells to make sure they match the cell underneath. If not, you paste the TMY data incorrectly, or there's a problem with your data. So what that's trying to say is this says dry bulb temperature and this says dry bulb temperature. They should say the same thing. If they say something different, there's something really wrong, and you're not going to get good results. So relative humidity, global horizontal, I'm just going to check this real fast and make sure. Diffuse, total sky cover, wind direction, wind speed, and that's good. Now this column here, for precipitation, it says find a reliable source and enter precipitation by hand. As we just saw in the TMY data, the precipitation numbers are rarely correct in this, and it can be misleading. So in this case we see it's all zeros, meaning precipitation was never collected. And so you need to find a source yourself. Now in this case, all I'd like you to do is find monthly data, which should be easier to find. You can find this even on like TripAdvisor or something like that. I'll show you a process that I go through, which is to just type in the name Stuttgart monthly precipitation and average monthly rainfall. That looks good. Usually I try to look at 2 or 3 sources because the internet lies a lot. Be nice to have it in numbers, but if I just get a graph, that's okay. So here it is in millimeters. So I can transcribe this into here by scrolling over. So January is about 58 millimeters, February is about 55 millimeters, March is 50, April is 61, May is 80, June is 85, July is 70, August is 65, September is 56, October 59, November 62, December 65, we'll say. And then January, this comes back again to January, that repeats there. It's a formula that says copy that one again. So now I'm going to take a look at another website, US World Weather Online. Let's see if this is any better, and see if I get similar numbers. Precipitation. Oh, now they've got actually got the numbers. That's helpful. So this looks like a very similar pattern. Don't forget to copy your source. So I'm going to copy this URL so I can find it later if I want. Source. I'm going to put it right in there, and that way I've got it for later. Okay. So that updates the precipitation, and if you want to check to see what that looks like, go to year, and at the bottom of this list you'll see the precipitation graph. This should look similar to what we just looked at. That's what's populated. While we're on this sheet, let me show you the rest of the graphs on the annual graphs here. So I'm going to go up to the top, and remember to always read this red text. it says to change the y-axis, right-click on the scale, select Format Axis, and enter the min-max values. Number 2, the temperature graph below is actually 2 graphs. The comfort zone is overlaid on top of the temperature graph. To change the temperature graph, you need to move the comfort graph. So what I'm talking about here is actually the second graph right here. This graph is 2 graphs overlaid on each other. I'll show you how this works. So if you click the first graph, you can press Shift and move it over. You'll see that that is just the 2 comfort zones, the comfort bands. And there's no other way to do this, unfortunately, to overlay the comfort band on top of the data. So I've had to create this kind of workaround. So I'm going to, actually, what I recommend you do is delete this, actually. And I'll show you why in a second. And if you want to change the vertical axis, because right now it's set to auto scale, I right-click and go to Format Axis. And over here, I can change this. So right now the boundaries are set automatically to -20 to 40. I can come back here and make them a little bit smaller, -10 to say 35, and see more of the data. It expands to fill the boundary. If I want to then go back to auto, I can press reset and it will go back to the auto boundary. So I'm going to just show you how to do this. If you keep this at a fixed boundary, the y-axis, then what we need to do is remake that comfort zone that is running through here so it can then get overlaid on top. So to do this, press Control-C, copy the entire graph, and I'm going to go right next to it and click Control-V, and that will copy the entire graph. But I don't want the graph, I just want this little comfort band. So actually what I can do is erase. This is kind of fun. I'm selecting these things and pressing delete, and I can erase everything and have only these comfort bands left. Now I think that one thing you're going to want to do is make sure that this stays fixed. So, because if I delete it, oh no, that's good. Alright, we're all good. Nothing bad happened. And the last thing is, notice this is a white background. I'm going to right click on that and say Format Plot Area. And you see it says no fill, no line. And actually need to click here in the chart area, and it's set to be a solid fill. I'll just make this another color so you can see what I'm talking about. That background. So instead of a fill, I'm going to make this no fill, and it will turn transparent. And then I can press Shift and drag this back so it's all lined up, and then visually just align it the rest of the way. Hopefully that's clear. Let me know if you have any questions about that process. And now that I've got the dry bulb temperature and humidity in a place where I want it, I can look at these other graphs and make sure they're good to go. Looks like these are just fine. So if you're happy with these, and you know it, clap your hands. No, just joking. Keep reading the red text. All graphs reference data on the Week tab. Remember to manually enter the precipitation data. This one does not automatically update. Okay, we've done that. We're good. Number 4, after you set up the graphs, print the page to PDF. Depending on the speed of your computer, this could take 2 to 10 minutes. It's a lot of data. Be patient. So I can go ahead and press File, Print, and again, you have to be a little bit patient. My computer is probably not as good as your computer's. But you see it comes up with a page here, and as long as this is set to print active page, it will just show the page that you're currently on. And you can, this is set to be tabloid. You can print this and it will print a PDF. I'm going to just save this to my desktop right now, and and here's the sheet. So this is the PDF. Now one thing, InDesign does not particularly like PDFs that have a lot of vectors on them like this one does. So what I recommend you do is save this now as a PNG file. To do that, this is pretty easy. You go to File, Export to, and you want to export this to an image, a PNG. So I'll leave this on here for a second so you can see it. Export to image, PNG. And under settings, just make sure that your settings are set like this. No grayscale, embedded RGB profile, and this should be good. So I'm going to save this as a PNG, and now I can import that into InDesign, and it should import really nicely. You'll reduce the overall file size. It'll be easier to work with. Now that we've got the annual graphs, let's go back to Excel and look at the weekly graphs. So I'm going to go over to week, and you'll see that over here on the right there's 3 sets of graphs. I'm going to zoom out. This is going to be really small, but you'll see what I'm talking about. Too much. There's 3 sets of graphs. One for a typical cold weather 3-day period, typical hot weather 3-day period, and a typical mild weather 3-day period. And these graphs should also autocomplete. However, what I want you to do is make sure that this is the right period. And I'll explain this in a second. So what I've done is programmed in here to look under the TMY data and find the week nearest the average temperature for the period. And it's saying that that's December 1st. And so let's just look at that. Where is that data coming from? Well, if you want to know, you can follow this link. So this is TMY data Q3, and I can go back to TMY data and go to Q3, that's December 1st. And you can see that this is the winter week nearest average temperature for period. And it is December 1st to December 7th. And while we're here, by the way, I'll show you some of the others. There's an autumn week nearest average temperature per period. That's October 13th to 19th. And then there's a spring week nearest average temperature, and that's March 29th to April 4th. And then finally, way at the beginning here is the summer nearest average typical temperature for period, which is 22nd of June to 28th of June. So in my week here, I'm actually reading that number, and these graphs are automatically updated to that date. So December 1st, December 1st. And this is a 3-day period in December. Now, the TMI data is pretty smart, but it's not as smart as you are. So I want you to make sure that you go through the annual data and make sure that this December 1st looks to you like it really is an average winter period. Same with the summer, same with the autumn or spring. And you have to decide for yourself what you think is right. This may or may not be correct as is. Now, if you think that it's something different, say you think that this should be, let's say, February 1st or February 3rd, then I can type in here February 2, 3, and the year needs to be 1995. So just make sure that you've got 1995 in there. And then this should automatically update all of these graphs. So you see now this switched to February 3rd to 6th. I want you to notice, however, that this graph down at the bottom does not automatically update, and that's because these guys are all line graphs, and I was able to program them to automatically update. This bubble graph or circle graph does not. So you have to manually go in here and update the dates. In this case, let me open this and you'll see what I mean. I'm going to right-click on the date, Format Axis, and you'll see that what it asks for is actually a number, not a date. Now, Excel has this way of working where it assigns all years a number. I think it starts at like 1900 or 0 or something, I don't know. But anyway, December 22nd, 1995 is the number 35,055. Don't worry about what Excel thinks it is, because I've got a little shortcut here to help you. What this is the translation of February 3rd, 1995 into Excel numbers. So Excel thinks that February 3rd, 1995 is 34733. And so the min should be 34733 and the max should be 34736. So I want to right click there and go to 34733, and then you'll see this gets really busy because now it's showing the whole year. And then 34736, and it should be the same 3-day period as above. Once you've checked to make sure that all of your typical cold weather, hot weather, and mild weather 3-day periods are correct and you're happy with them, then I suggest that you also look to see if the vertical axes are the same or different. So for instance, for temperature, you see that the max is 30 and the low is 0 in this graph, 0 and 30, and then 0 and 30. So they're all the same here. So it's easy to compare among the three different times of year. When we go down to solar radiation, though, you can see that the max here is 300, the max here is 900, and the max here is 500. And that makes it difficult to compare these because they all look kind of like they're the same. So what I would suggest is you pick the highest value, in this case 900, and then pin this, the vertical, fix it to be 900. So to do that, again, like we just did for the annual ones, click on the axis, right click, go to Format Axis, and under Maximum, type 900, and you'll see these all shrink. Same over here, I'm going to click on this and type 900, and they're going to shrink. So now we have a better comparison among these three graphs. You can see that the hot time is a lot hotter than the spring, which is a lot hotter than the, or there's a lot more radiation than the winter, which makes sense. Good. Cloud cover should always be 0 to 10, so that probably isn't going to be an issue for you. And the wind speed and direction, that shouldn't change either. So once you're satisfied with this, you can print this page as well. A similar way that we did the annual. Go to File, Print, and then we're going to print the active sheet. That's it. And I'm going to print this onto 11 by 17, so the little higher resolution. Print, and again, this could take a little while. So, oh, that was actually pretty fast. And there it is. And again, just like we did before, export this to an image so that InDesign is much easier for InDesign to deal with. And that's it for Excel. In the next video, we're going to take a look at another piece of software called Climate Consultant, and I'll show you how to generate psychrometric charts and sun path diagrams. See you there.